Hello everyone, welcome to Pepcoding. In this video, we will look at the question median of two sorted arrays. So let's see. In this question, we have two sorted arrays and we have to find the median. Now, what is a median? A median of a data set can be said as the middle value, right? So let's just take this example. We have 3, 5, 7, 9 and 12. For example, I have this data set. Right. My median is going to be 7 here because 7 is my middle value. So I can say that 7 is going to be my median here because it completely divides the data set into two halves. Okay, but you can notice something that this is of odd length nature. Right, we have odd length here. This array is of odd length. But what if I had an array which was something like this? Right, this is even length. For an odd length, I would have only one mid, right? It completely divides like this, right? But for an array with even length, I would have these two mids, right? I would have two mids. So for an array with even length, what is going to be my median? My median is going to be the average of these two mids, right? So these two mids, I would have the average of these two mids as my median value. So, so uh, what a median actually is? Median actually is represented as the middle value of a data set. And if the length is even, it is going to be the average value of the two mids. And if the length is odd, then it is going to be the mid value only. Okay. So let's discuss the approach. We can make a merge sorted array, right? We know how to make a merge sorted array. So let's make a merge sorted array for these two arrays. We would get 3, 4, 5, 6, 7, 9, 12 and 14, right? And let's index them 0, 1, 2, 3, 4, 5, 6 and 7. So my length is 8, right? This is my length. Now I have this merge sorted array. Now, what if I find the mid of this merge sorted array, right? My mid of this merge sorted array would be this. Since this is of even length nature, let's write it like this: even length, right? Or even size, because we are using vectors, right? So if the size is even, we would have my median as the average of two mids. So let's find the mid in this array, in this merge sorted array. I would get 8 by 4 or 8 by 2, right? My mid is going to be 8 by 2 because 8 is my size, and since I'm dividing it by 2, I would get the midpoint, right? So my mid is going to be 4. I would get this as mid, right? I would get this index as my mid, but I also need this index, right? So this index is mid minus 1. So I can say that my median for an even size array would be ARR of mid plus ARR of mid minus 1, and we are taking the average. Okay, so this is going to be my median for a array of even size. But what if I had an odd size array, right? What if my size was odd? Then if my size was odd, then my median was going to be the array of mid itself. And why is that? Because in an odd size array, there is only one mid. So for example, we have 3, 4, 5, 6, 7, 9 and 12. Okay, let's say I have this. So for this merge sorted array, my answer is going to be 6 only because we only have one mid and it is completely dividing this merge sorted array in half. Okay, so this is going to be my median, and here my median is going to be the average of the two mids because my length is of odd nature. So we already kind of know the approach. We just need to find the merge sorted array. So let's discuss how we make the merge sorted vector. Okay. Okay. So we are going to have two pointers. right? So we would have I here, j here, right? We would have two pointers and a pointer k here for my merged array. Now this I and this j will move and they will uh, check, right? So I'll check my I and j. If my I is smaller, so here I have my I is smaller, I is 3. I will print or I will push 3 here. Then I'll move k, right? And I'll move I. Then I'll compare again, right? I'm comparing again. J is smaller, so I'll add j and then I'll move my k and I'll move my j. Okay. Then I'll compare again I and j, right? I is smaller. I'll add I and I'll move I and I'll move k. Okay. Now I'm comparing again. J is smaller. I'll add j and I'll move j, move k and j. Right. So I'll compare again. I is smaller. I'll add I. Then I'll move k and I'll move my I. Right. Again, I and j are compared. I is smaller. 9 here. Right. K is moved and I is moved. Again, we compare. I is smaller. I'll put I and then I'll increment k and I'll increment I. Right. Now I has traversed all of the array length. So the remaining elements of my second array are going to directly be merged into my merge sorted array. So from this, right, this 14 is going to go exactly like that. And I have I've got my merged array. Now I just need to find 6 and 7 and then I'll find the average of these two and that would be my median. Okay, it's a very simple code. Let's do that. Okay. So first, let's find the size. That would be a1 dot size plus a2 dot size. Right. This would be my size for my median array. So vector of int merged, right, of n size. Now, let's not do that. Let's make two or three pointers, I, j, and k. Right. And I'll put I, j, k equals to 0. Right. So I have my 3 pointers. Now I have 3 loops to run. Right. So my first loop is going to be while I is less than equals to or less than a1 dot size and j is less than a2 dot size. Right. If this is smaller, then I'll run this loop, and that is that if the a1 of I value is smaller than a2 of j value. Right. If this is the case, then I have to add it to my merge sorted array. So merged of k will be equal to a1 of I. I'll increment my I. I'll increment my k. Right. Else, if we are in this else condition, then we just do the same thing, but for j. Right. Because here my value for my a2 value or my j value is smaller. Right. So if my j value is smaller, then I'll add it to my merged array. So after this is done, I will have my merged array filled, but it is also possible that one of the two are left, like one of the array is completely traversed and one is left. So I will put two while loops while I is less than a1 dot size. This is to check if there are any elements left in my uh, first array or a1, right? So we have this and then another while loop. This is to check if there are elements left in my a2 array. Okay, so we'll just copy this. Okay, so I've made my merged array. After these three while loops, my merged array would be completely filled, right? So I just need a median, or let's just make a median. So float median, and this is 0 right now. Okay, and I also need my mid. So my mid is going to be the array of, or let's say n by 2, right? This is going to be my mid. So after my mid has been found, now I just need to check that if my merge dot size is, or let's write it like this, n modulo 2 is equals to 0. This means that my merge size array is even, and if it is even, then my median is going to be the array of mid, or a1 of, or merged of mid, plus merged of mid minus 1 divided by 2.0. Okay, and else my median is going to be the merged of mid itself, and after this we'll just return this median. So we have found the median, we found the mid, then we checked if the length was, if the merge size array length was of even nature. If it was even, then the mid was going to be the merged mid plus merged mid minus 1 divided by 2, because it is the average of the two mids. Else my median is the merged of mid. Okay, so this looks fine. Let's run this. Okay, so there was some login issue. Let's see. This is my code, right? So let's run this. It is submitted. It's accepted. Let's submit this. It is also submitted. So I hope you understand this question. If you don't, I would suggest rewatching the part which you don't understand. And also, what is going to be my time complexity and space complexity, right? Or my time complexity is going to be n plus m, right? Because I'm traversing this whole, let's say this is of size n and this is of size m. So I'm traversing all the elements, right? So my time complexity is going to be n plus m, and I'm storing them in a merged array. So I'm using n plus m space. So my space complexity is also n plus m. Okay, I hope you understand this question. Thank you for watching.